like we're fractions of regular numbers or rational fractions. There's two types. One where you have the same denominator, one where you have different denominators. Let's do a couple where the denominators are the same. In addition, if the denominators are the same, and they are, we add the numerators. 3x plus 7x, 10x. 2 plus negative 4. 2 plus a negative 4 is 2. Excuse me, is negative 2. And I guess we should factor out the 2, and 2 times 5 is 10, times x is 10x, minus, and of course 2 times 1 is 2. So there's the answer. The denominators are the same, add and subtract normally. You have to know how to add. You just have to. And subtract. 3x minus 4 minus 3x minus 4 plus something over 3x minus 4. 3x squared minus 7x plus 9 minus 4x squared plus 3x minus 11 negative 3x squared minus 4x plus 13. We're adding three fractions. The denominators are all the same, so we keep the common denominators. 3x squared minus 4x squared plus negative 3. How much is 3 minus 4 plus a negative 3? 3 minus 4 is negative 1. You add on negative 3, get negative 4. Negative 4x squared. It's just 3 arithmetics. Negative 7 minus 3x's plus negative 4. Negative 7 take away 3 is negative 10 plus a negative 4 is negative 14. Okay, negative 14x's. Now the constant. 9 minus negative 11 plus 13. 9 minus negative 11 is 20. And if you add 13 to it, you get 33 plus 33. And there's the answer, plus 33. It was just 3 arithmetic problems. Add the numbers and combine the numbers in front of x's, x squares, excuse me. Combine the numbers in front of x's. Combine the constants. That's it. Combine means subtract and add accordingly. Try one more like this. Your teacher will tell you to change subtraction to addition. I have no idea why you would do that. Subtraction is not a bad thing to do. Subtraction is not a bad thing to do. And once again, the denominators all the same. I didn't mean to write it out of order, but I did for the last one. Okay, so you have 4x cubed minus 7 minus 3x squared plus 4x plus 11 minus x cubed plus 4x minus 13. We're subtracting fractions. They all have the same denominator. Well, no. I see x cubes. I see constants. I see x squares. I see x's. And I see more constants and x cubed and x's and constants. X cubed, then to write it more to the left. So we have 4 arithmetics to do. We have 4 arithmetics to do. And we've done this earlier. X cubes. We have 4 of them. We are not taking away any from here, but we are taking away, and this did 1x cubed. So we have 3x cubed. Okay, 3x cubes. Now x squared. We have none here, but we are taking away 3 of them. And then we are taking away, well, none over here. You want to take away 0? Go for it. But the bottom line is, we are taking away 3x squared. If you wrote take away 0, you still get negative 3. You want to put that 0 in front because the first fraction didn't have any sign. X's. The first has none. You want to write down 0? Fine. Minus 4x's. Minus 4x's. That's negative 8x's. Negative 8x. Constants. Negative 7 minus 11 minus negative 13. You work this out, and I guess we're going to get negative 5. Negative 7 minus 11 is negative 18. And instead of taking away a negative 13, you add 13, which is negative 5. And there is your answer. Okay. Just like the section before, adding and subtracting polynomials. The denominators are the same. You just combine the numerators. Either add or subtract. Possibly both. It depends upon the sign in the middle of the fractions. Now, what if the fractions have different denominators? What if you have 3x over x minus 5, and you want to add 14x over x plus 3? First thing you have to do is find the least common denominator. So you want to find the least common denominator. The first thing you do is you factor the first denominator, which really can't be factored any further. And then you factor the second one, x plus 3, which can't be factored any further. Okay, now that you have all the denominators factored, you ask yourself, did you write down x minus 5 in the lower left-hand corner? And the answer at first is always no, because you didn't write down anything yet. Okay, then you go to x plus 3 and you ask yourself, did you write it down in the corner? The answer is no. And there's no more denominators. There's no more denominators. So here is your least common denominator. You want to write both of these fractions on top using this denominator. That is, I want to change the way this fraction looks. I want it to have a different denominator. If you want to change the way something looks, that's code for you want to multiply by 1. Since you want an x plus 3 in the bottom, then you better put x plus 3 on the top. Plus 14x over x plus 3. Well, I want this denominator. I have the x plus 3. Here it is. I need the other factors. In this case, there's only one other factor. I need the x plus 5. So I multiply by 1 as x plus 5 over x plus 5. Now, there are possibly people out there screaming that, oh, x minus 5, excuse me. There are people out there screaming that may not be 1. Very good. Scream loud. what's in red may not be 1. This is true. First, let me make this really look like x minus 5. Okay. It may not be 1. X plus 3 over x plus 3 may not be 1. And that will happen when x is negative 3. But if this initial problem is going to make any sense, then this denominator can't be 0. It's kind of implicit that x plus 3 is not 0. It's understood that x minus 5 is not 0. Otherwise, the problem makes no sense. Alright, so now I'm adding two fractions. They both have the same denominator. You should not multiply out the denominators. Just leave it as x minus 5 times x plus 3. The numerator is this numerator plus this numerator. The first numerator is 4x squared plus 12x. 4x squared plus 12x plus 14x squared minus 70x. 14x squared minus 70x. And when we add 4x squared plus 14x squared, you get 18x squared. Positive 12 plus negative 70 is negative 58x. Divided by x minus 5 times x plus 5. Now the thing is after factoring out the numerator, which I'm about to do, if we get an x minus 5 factor or an x plus 3 factor, we can cancel them out. But we won't see that if we multiply out the bottom. Okay, 18. I guess only 2 goes into it, 2x. So you have 9x minus 29 over x minus 5 times x plus 3. And there's your answer. The key part was what I did in the bottom left-hand corner. Write down the different factors. You have 5 over x squared y cubed z to the 4th minus 3 over xy squared z to the 5th plus 4 over x squared y to the 4th z. Factors are things that are being multiplied. X squared times x cubed times z to the 4th. So the first factor is x squared. I didn't write it down. Now x squared means x times x. X squared. Y cubed. I didn't write down the y cubed yet, as I didn't include 3 factors of y. And then z to the 4th. 1, 2, 3, 4. Z to the 4th. I need an x. I already have at least one x, and there it is. I need y squared. Well, y squared is already in here. I do have y times y. I need z to the 5th. I only have z to the 4th. I need another z. Make that z to the 5th. I need another z. I need x squared. Well, I already have x squared. I already have 2 factors of x. I need y to the 4th. I only have 3 y's. I need one more. I need need one more. I need one more y. I need 4 of them. And I need a z. Well, I already have a z in here. There it is, for example. And there's the answer, the LCM. There it is. That's what I want all 3 denominators to become. X squared, y to the 4th, z to the 5th, x squared, y to the 4th, z to the 5th, x squared, y to the 4th, z to the 5th. The first denominator on top. We have the y, the x cubed, the x squared, the x squared. We need y to the 4th, but we only have 3 of them. The top and bottom get multiplied by y. I need z to the 5th, but I only have z to the 4th. So top and bottom get multiplied by z. That gives me my 5th z. So the numerator is 5yz minus. Okay, for this denominator, well, I need x squared. I only have x. So I multiply top and bottom by x. I need, let me look here. I need y to the 4th. I only have y squared. So I multiply by another y squared. And I need z to the 5th, which I have. So it's minus 3x y squared for the numerator. The next fraction. I need x squared, but I have it. I need y to the 4th, but I have it. I need z to the 5th, but I only have z. So I multiply by 1. Z to the 4th over z to the 4th. So the numerator will be 4 times z to the 4th. And now I'm ready to write down the final answer. Do it right here. The bottom's not changing. So basically just copy it down. Copy down the numerator. 5yz right here minus 3x y squared minus 3x y squared plus 4z to the 4th. And in terms of numbers, nothing goes into 5 and 3. In terms of y's, I have a y in the first factor, a y in the second, but no y's in the third. In terms of z, I have z in the first, and I have z's in the second, but no z in, I meant to say the third, but no z's in the middle. So there is your final answer. There it is. Let's try this one. This will be our last one. 3 divided by x squared plus 3x minus 4 minus 4 over 4x squared plus 5x minus 9 x plus 2 over 4x squared plus 25x plus 36. As I said before, you need to know the factors. You need to factor these denominators. This denominator here is going to be x plus 4, x minus 1. The next one, this is going to be hard. 2x. You can try factoring that by grouping. I don't think that 3 is going to work. 9 teach you how to factor in this section. By factors or denominators. I need x plus 4 in the corner. I don't have it. I put it down. I need x minus 1. I don't have it. I put it down. I need 4x plus 9. I don't have it. I put it down. I need x minus 1. I have it. I don't put it down. I need 4x plus 9. There it is. I don't put it down. I need x plus 4. I already have it. There is my LCM, or my LCD. That's the denominator I'm going to use. X plus 4, x minus 1, 4x plus 9. The thing is, you have to know how to factor. Okay, first fraction. It has the x plus 4 and the x minus 1. It needs 4x plus 9. So I multiply top and bottom by just that. The second fraction. It has the 4x plus 9 and it has the x minus 1. It needs x plus 4. Okay? X plus 4 on the top, x plus 4 on the bottom. The last fraction. It has 4x plus 9 and it has x plus 4. It's missing x minus 1. So I multiply top and bottom by x minus 1. I do their multiplication. Get 12x plus 27. 12x plus 27 minus 4x plus 16 plus x squared minus 1x, but then add back 2 x's. That is plus 1x. And then take away 2. Alright, and the denominator has not changed. X plus 4, x minus 1, 4x plus 9. And we combine the x squares. We have 0 here, minus 0 there, plus 1x squared. Now we deal with the x's. 12x's minus 4x's is 8x's plus an understood 1x. It's 9x. Now the numbers. 27 minus 16 is 11 plus negative 2. That's like 11 minus 2, which is 9. And I don't think that can be factored. If I'm mistaken, then factor it. But there's the answer. Remember, if, and this is not the case, if the numerator happened to factor out the x plus 7 times x minus 1 over, the bottom's not changing. All I'm saying is that when you cross this out, I want you to say that you get x plus 7 over x plus 4 times 4x plus 9, provided that x is not 1. Because this does not cancel out to 1 if x is 1. 1 minus 1 over 1 minus 1 is not 1. It's 0 over 0 or indeterminate. Okay, let's do one more. Have to factor the denominators if need be. Find the least common multiple. Then you write each of these denominators with the new least common denominator or least common multiple. And then you are here to subtract the numerators. So, what if you have a over a minus b plus c over b? A common factors. A minus b, I haven't written it down yet, in b. Generally, you wouldn't put b on the end, you would put it at the beginning, but that doesn't matter. The final denominator will have b times a minus b. Well, the first fraction, it has the a minus b. Here it is. It just needs the b. So multiply top and bottom by b. The second fraction, it has the b. It has that b. It needs a minus b. So multiply top and bottom by a minus b. So you get ab for the first fraction, ab plus, says plus, ca. If you want to write ac, go for it, minus cb. So you have ab plus, I'll write ac, plus, minus, and I'll write bc. I'll call that bc. All over b times a minus b. And anytime you have fractions or what have you should ask yourself, can I factor? I mean, I see an a in this term. Oh, there's an a here. There it is. But there's no a here. The a couldn't be common. Well, there's a b in the first factor. There's a b in the third factor. There's no b in the middle. So that's it. Okay, there is the final answer. Okay, that completes this section. Good luck with it.